So good evening, everyone. And for next 2-3 days, let me give you the plan. So we are going to cover 2-3 very important topics of electronics. Okay. So first of all, whenever we have electronics, we have three systems. One is three components R, C, and L: resistor, capacitor, inductor. We call them as the passive elements. Passive elements means that they cannot work on their own. You need to apply some voltage so that they work. So when you have these three components, which kind of voltage do you apply? Do you apply DC voltage or do you apply AC voltage? Okay, both of them are the possibilities. You apply DC, sometimes you apply AC also. Okay, when you apply DC to resistor, what is it like? It is like a AC or anything, any device whichever has a resistance. When the direct current passes through it, right? It is called as the normal resistor and normal DC current. Battery. DC current means battery. AC current means transformers. Okay. Then comes capacitor. And is this class? Yes. For jam, it is very important. Very, very important. Then comes for capacitor and inductor. One thing is very clear. Let me ask you this question. If I apply DC voltage to capacitor or if I apply DC voltage to inductor, does the current change with time?
No, sir.
I am applying DC current voltage to constant voltage to inductor and constant voltage to capacitor. Is the current changing with time?
No, sir.
Everyone in the chat box, ऐसा सुस class नहीं मुझे चाहिए. Everyone in the chat box, yes. Does the current change? Yes or no? Only one correct answer, yes. What is a charging of capacitor? What is like you charging your mobile phone? Your mobile phone is a capacitor. So do you think that with time you have not studied this kind of graph, RC circuits?
Yes.
Even if you apply DC current, even if you apply DC voltage, your current can change with time in case of capacitor and in case of inductor, because their effect is there. They are reactive elements. They react to the voltage applied. So we will be studying this topic in 3 days in 2 steps. Number 1 step will be, we will be applying AC voltage. Alternating current voltage itself we will apply. And the second step will come when I will apply the DC voltage. In DC, you see charging, discharging, LC oscillations, these kind of things you must have aware about. And in AC, you will be seeing something known as resonance, or you will be seeing something known as XL, XC, 1 by omega L, omega C. So that kind of things, phasor treatment, these things you will see in the AC components. So two categories we will be have. After every class, you will be getting a sheet of 15 to 20 problems, 15 problems, very easy JEE mains level problems will be there. Direct formula based questions, some application. You must practice those so that your formulas gets revised. So let's begin. Okay? So today we are going to understand what happens if I apply R, L and C to AC. Yes, this class is being recorded. Yes. So you have R, L and C and you are applying AC voltage. AC voltage is very simple. This is your direct current and this is your alternating current. Alternating current basically means alternating voltage basically means in which your voltage is changing with time. It simply means that in which your current is changing with time. So that becomes alternating. Your source itself is alternating. There are two different things. Number one thing is that your source is giving the alternating current or voltage. One is that your current or voltage is changing with time in circuit. These are two very different things. If in your circuit, you have a total circuit, and in your total circuit, the voltage is changing with time or the current is changing with time, that is a second issue. First thing is, if your battery itself is giving the current or a voltage which is changing with time, basically the battery ka voltage itself is changing with time. So for batteries, it is not possible. If you bring 9-volt battery, it will remain 9-volt forever. But what can happen is if you apply transformer, in transformer, the voltage source itself is alternating. Okay. So that is a very important step. So today we are focusing on the source. Source itself is supplying the voltage which is changing with time. Okay. So whenever something change with time, usually we represent it with the sine or cosine wave. Obviously, the change with time can happen with any function. It can be the step function. It can be the sigma function. This can be the heave side function. Many things can happen. But in our physics, the most important or the most applied one is the sinusoidal change or the harmonic change, in which the current and the voltage is changing with time according to the sine or cosine wave. Okay? So the first question here comes, and this question everyone have to answer, and everyone has to guess. If you don't know the answer, guess. If you know the answer, tell me the answer. You have two waves. One is cos wave, cos theta wave, and one is sine theta wave. What is the phase difference between them? What is the phase difference between them?
Pi by 2.
5/2.
90 degree. Okay, everyone knows it. My main question: who is ahead of whom? Sine theta is ahead or cos theta is ahead?
Cos
Who is
Cos theta.
cos theta.
cos theta? Okay, very good. Let me draw the graph. So this is sine and this is cos. Okay, this is your cos. Okay. If I make this cos little bit backwards, like this, does your cos also looks like sine? Just
Yes,
I'm
sir.
just bringing
Yes,
cos
sir.
on little bit. So now looking at this diagram, who is ahead? This red sine or this blue cos?
Sine.
Sine.
हाँ भाई, क्या मैंने आपको 1 मिनट में कंफ्यूज कर दिया? Every one of you gave the answer. Cos is ahead. Now I just gave you the diagram, and now what is your answer? Who is ahead? 90 डिग्री से एक आगे है. One person is ahead by 90 degree. Who is ahead? Who is winning the race? Is the answer still cos or is it sine now? Very quick. जल्दी जल्दी करेंगे हम. बहुत कुछ कवर करना है. Yes, everyone in the chat box एक बार बता दो. According to this graph, what do you think? Who is ahead? Many people still say
The point
cos
of
and
reference matters कि आपने किस point
no,
से
no,
उसको
there is no point of reference. Very simple idea. Cos is ahead. Some people say sine. So let me clarify this concept for you. See, concept क्या है? Who took birth before? If both are sine, let's say both waves are sine waves, because both of them looks like sine. If both are sine waves, this is your, actually it is cos wave, but let's say both are sine wave, then who took the birth before? This person took the birth before, and this person took the birth after. So who is ahead? Who took birth before or who took birth after?
Before.
before.
Before. जिसने पहले जन्म लिया वही आगे होगा ना. For example, if I am 1 or 2 year older than you, it means I am little bit ahead of you. That is only because of the time, because I took birth before you. That's all. Similarly, our fathers took birth before us. So still, by looking at the diagram, you don't say that sine is ahead. You say still cos is ahead because cos took birth before. Okay. So that is why cos theta is always, remember, cos theta is always
Ahead.
90 degree ahead of sine theta. Okay. So now you have to tell me this. One you have is minus cos theta and one you have is plus sine theta. What is the phase difference between them? Jaldi
Still
jaldi.
90 degree. Cosine is an even function.
90 degree. Who is ahead?
Cos itself.
Cos.
अभी भी cos बोलोगे आप? Let me make the minus cos graph. If I make the minus cos graph, do you think this will be the graph? Yes, this is the graph. minus cos का ग्राफ, अगर I have to
Yes,
make
sir.
minus cos का ग्राफ,
Yes.
this is a minus cos graph.
Yes.
So do you think now it is like sine wave, but it is taking birth after? This minus cos, this is minus cos theta, and but it looks like a sine wave, but this sine wave is now taking birth later stage. Yes, क्या ये
लेकिन
बात
सर
सही?
माइनस में भी तो है वो।
हाँ, तो फिर इतना थोड़ी पीछे, वो तो फिर आप पूरी एक वेव ही पीछे चले गए। So देखो
तो
स्टार्टिंग
साइन
में क्या
वाला
था,
भी है।
this was 90 degree plus, this was plus 90 degree and this was at 0 degree. यही बोल रहे थे आप कि this person is ahead. The moment you multiplied by negative, negative is equals to how much phase difference? Negative means how much phase difference?
180 degree.
180 degree ahead or back? Plus 180
Back.
degree, 180 degree, minus 180 डिग्री। अगर मैं प्लस 90 में से माइनस 180 डिग्री करूं तो क्या होगा? minus 90 degree, and this still remains 0 degree. Now who is ahead? Now you tell me who is ahead? Sine. Can you understand? Do you understand the entire concept? Everyone understood? समझ आ गई भाई? Cos theta and sin theta में who is ahead, and minus cos theta and sin theta में who is ahead? Any doubt? Anyone has a different answer? Please let me know. ये बड़ा इंपॉर्टेंट है, बहुत जल्दी जल्दी हमें जो है चलते जाना है।
Sir, in conclusion, that in cos theta and sin theta, cos theta is ahead, and minus cos theta and minus sin theta, the sin theta is
माइनस
ahead.
cos theta and plus sin theta. Sin theta is still plus.
Okay.
And so sin theta remain plus. I just made cos theta minus. Okay. Now very quickly, now you tell me what is the phase difference between them?
5/2.
बोलो भाई. Is it still? बताओ. 90 degree. Who is ahead? Who is ahead?
Minus sin.
Minus sin is ahead or cos is ahead?
Minus.
Cos theta.
Cos.
This is cos. ठीक है. And this is minus sin. Either you make both of them cos or you make both of them sin. So what can we do? Every time graph does not help. So what do we do? Either you make both of them cos or you make both of them sin. One thing you have to do. One thing you have to ultimately do. So can I make cos sin? कैसे कर सकता हूँ?
So cos 5/2 plus theta is minus sin theta.
Can I do this? Or let's do this.
Yes, sir.
Let's do this. ये अब ज्यादा आसान हो जाएगा.
91.
और लेट्स से थीटा minus 90 और 90 में नेगेटिव अंदर ले जाता हूँ. क्या ये सही है? क्या ये चीज यही बनाएगी? सॉरी, क्या cos थीटा minus 90 मुझे minus sin थीटा
Yes.
देगा? आप करके देख सकते हैं.
Yes.
cos थीटा minus 90 will be cos 90 minus थीटा. ठीक है. और cos 90 नहीं, ये थीटा प्लस 90 करना पड़ेगा.
It will give
ठीक है.
sin theta.
तो नहीं, यहाँ थीटा प्लस 90 करना पड़ेगा. तो अगर मैं इसको करता हूँ cos 90 प्लस थीटा, तो ये मुझे क्या देगा? माइनस साइन थीटा.
Minus
परफेक्ट.
sin.
cos 90 प्लस थीटा इज माइनस cos थीटा. तो इसका मतलब मैं इस चीज को ये लिख सकता हूँ. तो ये है cos थीटा और ये है cos थीटा प्लस 90. कौन आगे हुआ फेज में? फेज में कौन आगे हुआ? ये आगे हुआ. और ये कितना आगे? क्योंकि ये थीटा है एंड दिस इज थीटा प्लस 90. सो दिस थिंग इज अहेड. सिमिलरली यू कुड हैव डन द सेम थिंग हियर. ठीक है. यू कुड हैव डन द सेम थिंग हियर. आप इसमें कर सकते थे. इसको मैं क्या लिख सकता हूँ? साइन 90 प्लस थीटा.
Theta.
ठीक है. और बिकॉज साइन 90 प्लस थीटा विल गिव मी माइनस कॉस थीटा, और आई कैन से साइन थीटा प्लस 90. ठीक है. तो ये अब आगे हो गया, ये पीछे हो गया. तो हमेशा इस तरह से आप देख कर यू कैन ऑलवेज फाइंड आउट. So this is
Sin
always a
90 plus theta would be cos theta.
हाँ जी.
Sin
Sorry.
90 plus theta would be cos theta.
cos थीटा हाँ वही. इसको थोड़ा सा सही करो, इसको नेगेटिव कॉस बना लो, इसको नेगेटिव कॉस बना लो, वो ज्यादा इजी रहेगा. तो यू कैन डू मैथ्स, मतलब बेसिकली मैं मैथ समझाना चाह रहा था कि यू डू सम ट्रिग्नोमेट्रिक थिंग्स and you should always try to understand. So I can even give you some practice. So in this, so you understood with the graph. This is ahead by 90 degree. Now try to find out that who is ahead in this and what is the phase difference between them. Then try to find out who is ahead in this and what is the phase difference between them, and then find out who is ahead in them. तो इन चारों में पता करने की कोशिश करो कि who is ahead of whom. ठीक है. So this will be your homework. Very important because these kind of things will be asked in an exam indirectly. Question के अंदर it will be used. Okay. Second thing, once we have cause and everything, we write the statement like this, that my current is changing with time like this and my voltage is changing with time like this. This is known as the maximum current, or this is known as the maximum voltage, because if you have a sine wave, you have a maxima. This is also known as amplitude. So your voltage goes between these two values, plus V naught to minus V naught. This entire thing is known as phase. Entire thing inside the sine or entire thing inside the cos is phase. And this is known as initial phase. This small phi is known as the initial phase. Phase at time t equals to 0. What will be the phase when time is 0? Because if the time is 0, this is gone, phase will be this. So overall, anything written inside sine is known as phase, and this thing is known as initial phase. So all of this clear? Yes. यहाँ तक कोई doubt?
Yes.
Time and frequency, all those things you already know. Okay. Then for any current or for any voltage, we always find RMS value, and our instruments always measure RMS values. Our instruments, average and RMS are two different things. If you find out the average of current, it will be 0, because half of the time current is positive and half of the time current is negative. So the average is going to be 0. So average of your sine wave or the average of your cos wave is always going to be 0. Then I defined something known as RMS value. Always remember, understand it in the inverse form. RMS means root mean square. So if this is your current, sorry, I naught sine omega t. So the first step that you do is square. So you do the square, you get I naught square into sine square omega t. By doing this, I make sure that my graph never becomes negative. So you can now clearly see that my current is like this, because I have done the squaring. Second thing that you do is mean. So now you have to find the mean of I square. So you find the mean. And the last thing that you do is under root. So you do the under root of this. So you get this. So this will give you the value of IRMS. Okay. So first you do square, then you do mean, then you do the under root. That is why we call it as root mean square value. A very important result is that how do you find the average of any quantity? Any periodic quantity which is changing from 0 to t. So your sine is going from 0 to capital T, t is a time period. Your cos is going from 0 to capital T, t is a time period. I hope you are all writing this down. बहुत जरूरी है ये. इन चीजों को जल्दी जल्दी थोड़ा थोड़ा, please keep noting it down. So how do you find the average of any quantity? Any quantity, it is given by 1 by t. T is the time period, total time period. Then you put capital A. You are finding the average of capital A, so you write capital A and then dt. And the integration limits go from 0 to t. This is the definition of average. In this entire step, I have to find an average of what? I have to find an average of
Sine
sine
square
square
omega t.
omega t. So I have to find an average of sine square omega t. So what I will be doing is, I will be putting my value here. If I need to find the average of sine square omega t, I simply need to put sine square omega t here. ठीक है? So for that, I'm giving you some important integrations which you can try out also. So if you find the average of sine, obviously you get 0. If you find the average of cos, obviously you get 0. If you find the average of sine into cos, again you get 0. But if you find the average of sine square omega t, you get half. If you find the average of cos square omega t, you get half. Okay. So basically, I'm giving you the value of these important integrations. Okay. So please note down this formula for average, this meaning of RMS, and these important integrations. Very quick. And the moment you are done, write done in the chat box. Okay. Chat box में done mention करो and then we go on. ये इंपॉर्टेंट चीजें, ये टिप्स पे रहनी चाहिए. वी शुड नो दिस ऑन टिप्स. ये तो आई नो एनी टाइम, एनी डे यू आस्क मी दिस क्वेश्चन, आई नो दैट व्हाट इज sin स्क्वायर ओमेगा t का एवरेज.
थोड़ा zoom out कर लेंगे.
थोड़ा
बस जूम आउट कर देंगे.
जूम आउट कर लेते हैं. लीजिए. Done. Bhargav is done. Very quickly note down everyone. Don't take screenshots, write always, okay? Never take screenshots. चलिए भैया आगे बढ़ते. Okay. So then let's quickly find the RMS value of current or voltage, whatever. So if your current is given by I equals to I naught sine omega t, first step square. So I do the square. Second step mean. So mean I square ka mean. So this is a constant number, so this remains as such. And then you have to do the mean of this. I have already found the mean of this, which is half. So I naught square by 2. And then the last step is root. So you do, so root of this will be I naught, and the root of 2 will be 1 by root 2. So this formula you might have seen many times, right? ये आपने बहुत बार देखा होगा. IRMS is equals to maximum value divided by root 2. VRMS is equals to maximum value by root 2. It basically means very simple thing. If your instrument is measuring the voltage 220 volt, that is your RMS voltage. In today's class, I'm not going in deep that what is the physical significance of RMS because we are little bit training for exam of gate. But VRMS is 220 volt. It means the maximum voltage in this current is VRMS times root 2, which will be 311 volt. It means when you experience this current, although the RMS value was 220, the maximum value of voltage in this was 311. But your body will feel 220. Okay. Why does your body feel 220? What is the meaning of the feeling 220? Anyone? Why is your body not feeling 311 and it is experiencing 220? Anyone? How does your body feel current?
Sir, this 311 volt would be only at two time in one time period.
देखो वो बॉडी को थोड़ी पता है, बॉडी ग्राफ बना के थोड़ी बैठी है. तो देखिए आप मुझे एक बात बताइए, if I give you the current, what will happen to your area where I'm giving you the current? What will be the effect on that area? What will you have? क्या होगा उस करंट की वजह से? आपकी स्किन पे क्या होगा? What will happen on your skin?
Vibration and sensation.
Sensations.
ये मैं आपको मसाज नहीं दे रहा हूँ, मैं आपको करंट दे रहा हूँ. क्या होगा आपकी बॉडी में?
Heat will be lost.
बर्निंग हो जाएगी ना आपकी स्किन. योर स्किन विल गेट बर्न, राइट? Your skin will get burned. You will have fire. That is why we see people getting a very high current gets fired up. Burn. Burn means what? Heat. Heat is equivalent to kinetic energy. Yes. Heat is equivalent to kinetic energy. Does kinetic energy means square? Square. Square करेंगे सबसे. Kinetic energy का first step क्या होता है? Square. So first step was square. Second step. Do you find kinetic energy everywhere, or will your body will have the average kinetic energy? Average. So the second step is what? Average. And the third step is I'm simply basically converting into the voltage unit. So since I squared in the first step, in order to remain the same units, I again have to underroot in the last step, because I'm quoting the answer for voltage. I'm not quoting the answer for V square. That is why in the last step I did the underroot again, so that my final answer is in voltage. That is why you do square. That is why your body is experiencing square, because your body is experiencing heat. Heat is basically equals to kinetic energy. Kinetic energy involves square. That is why RMS value is felt, not the instantaneous value. Everyone with clear with this idea? Yeah, your body experiences heat because of current. Okay? Yes, I hope it is clear. Next, if I give you current like this, you see, this is the current. If I have to draw the graph of this current, do you think this graph is correct? Yes. The graph of this current. All I have done is what? What I have done? Simply, I have added a constant. So my entire graph will get lifted up. My entire graph will get lifted up. So do you think that this current will also have an RMS value? What will be the RMS value? Will it depend upon A, or it will only depend upon B, or it will depend upon both A and B?
A and B.
Both.
Both. What do you think? I think it should depend upon both A and B, because if I give you this current, won't you get burnt because of this also? Yes. Will you get burnt because of this also? Yes. So both A and B should be there. Again, how do you find the RMS value? पहला स्टेप क्या है? स्क्वायर. स्क्वायर करेंगे. A square plus B square cos square omega t plus 2AB cos omega t. Then second step, average. इसका average क्या होगा? Simply it is just a constant. So constant का average is equals to constant. The average of 2 is 2. Right? इसका average क्या होगा? Will it be B square by 2? Yes. Because it is constant and cos square का average is 2. 1 by 2. And इसका average क्या होगा? Quickly. What will be the average of this thing?
0.
0. So ये 0 देगा, ये b square by 2 देगा, ये a square देगा. So overall I get my a square plus b square by 2. What is the last step? Under root. That is my IRMS. I hope the concept of RMS is clear. And I can
Yes.
give you now any voltage, any current, you can find RMS. So this will be your homework. Can you do this very quick? Yes, मतलब कर लेना. Try to
Yes.
do it. Okay. So now I have understood everything about the source. Source is giving me AC voltage, source is giving me AC current. Now let's put this source to resistors, capacitors, and inductors. So first of all, let's put with the resistor. So this is my voltage. Okay, first you decide source. Who is going to be your source? So my source can either be a voltage source, or my source can either be a current source. So if you are giving a current source, it means you cannot change current in the system because you are giving that current. And if you are giving the voltage source, it means you cannot change the voltage given in the circuit because you are giving the voltage from your side. We always choose most of the time voltage source. So I am giving the voltage source. And this is my source. This is not like this. This is not a battery. This is a AC source. So that is why the symbol is given like this. This voltage is given by V naught sine of omega t. Okay? Always choose your sources as sine. The reason being because sine means zero level. Okay? So sine, because at time t equals to 0, your voltage is 0, so 0 level. You can choose cos also, that is not a problem. But choosing sine is just a convenience. Okay, if this is my voltage, then what will be the current in this circuit? So current will be given by Ohm's law, V by R. Okay? So this is V by R. I put the value of voltage. Okay, this thing can be written as I naught. Okay?
V
I
by
naught is
R.
given by V naught by R. This is the thing. And here you have the sine omega t. So current is given by I into I naught sine omega t. Very interesting thing. If your voltage was sine, then your current is also sine. Only difference is the magnitude of the voltage was more. The magnitude of the current is less. Not magnitude, amplitude. Amplitude of the current is less. Why? Because it is V naught divided by resistance. amplitude of the voltage was only V naught, but both are sine. Both are sine. It means both of them are in the same phase. There is no phase difference between them. So there is no phase difference between resistor and a current and a voltage. If you are having a resistor, it means there is no difference in phase between current and voltage. Current and voltage are in the same phase. Okay. Clear to all? Pehla is clear. Resistor is simple one.
Yes.
हाँ जी, चले भाई आगे एवरीवन, क्या बोलते हो, सभी चले? Okay, now let's apply inductor. So before I go for inductor, let me just explain in a minute that what is inductor, because we should know that what is inductor. That is also important. Okay, what is inductor? Anyone like to take a guess? What is inductor?
Coil.
This is a symbol of inductor. This is a symbol of resistor. What is inductor?
That stored
Okay,
energy.
let me ask you.
That store energy in magnet.
Store energy, बहुत सारी चीजें आपने बोली. Let me ask you a very simple question. If this is your air conditioner, ठीक है, and I apply AC current, so this is your air conditioner AC, which you use in the summers. Does this AC have inductance? Does this AC has inductance?
Yes.
Does this AC have resistance?
Yes.
Yes. Does it mean that inside this AC you have a coil fit? क्या ये सही है? क्या AC के अंदर coiling लगी हुई है? Is there any coil inside a AC?
Yes, sir.
No, not necessary. You don't have a coiling inside a AC. You have a semiconductor chips. You have a semiconductor. If you ever open a AC, air conditioner, you know motherboard and everything like that there. So do I need to put this coil in order to have an inductance, or any device in itself will have an inductance?
Any device will itself has inductor.
So that is my point. Any device in itself behaves like a resistor, inductor, and capacitor. You don't have to actually put this there. You don't actually have to put this there, or you don't have to actually put this there. Every device has a ability to resist current. Every device has an ability to resist change in current. देखना जरा, बात मेरी सुनना जरा ध्यान से. Resist change in current, and every device has an ability to store energy. What does inductor do? Does it resist the current, or it resist the change in current?
Change in current.
Change in current. It means if your AC is there, this is your AC, this is your air conditioner, and I am applying 12 volt. Does your AC have inductance? No. Now what I did is I tried to make this voltage 12 to 13. When I am trying to make this voltage from 12 to 13, during that time, does your AC has L?
Yes.
Yes.
Yes. So your AC do not have any coil. Your AC is an AC. But simply whenever you try to change current through any circuit, that circuit in itself, because of so complex components, try to resist that change. Try to resist that change. That is why that system will have the inductor. So whenever we see inductor, it itself means that your system is trying to resist that change. It is like a Sheldon Cooper. No, everyone knows.
Yes, sir.
He is basically trying to resist the change. Once you are able to bring that change, then he is comfortable. Okay? Once you bring that change, then he is comfortable. Then your inductance is gone. And what about capacitor? Okay, does every metal have some ability to store charge? Every metal has some ability to store charge. क्या बोलते हो? क्या हर एक metal charge store कर सकता है? And can you guess any device, electronic device, which does not contain metal? No, every electronic device has to have metals. So it means every device has some ability to store charge. It means in every device, R, L, and C are there. We simply study them with these symbols. It does not mean I directly have to go and put this there. No, never. I never go and put them. It is the intrinsic properties of a circuit to have these three. I hope it is clear. So now I'm trying to talk about the inductor. Inductance means resist the change. It does not resist the current, it resists the change in current or change in voltage. Okay, which law holds it? Which law controls this? Which law says that you have to resist the change in physics?
Lenz law.
Let's law.
Okay,
Lenz law.
Lenz law tells you direction, but which law tells you magnitude?
Faraday's law.
Faraday's law.
Faraday law
Faraday.
says minus d phi by dt. Everyone
d phi by
agree with
dt.
me?
Yes.
Okay. And what is flux? In
Magnetic
terms of
field
Magnetic
into
field and
Li.
electric field.
flux,
L-
can be written as Li. है
L-
ये अगर आपको थोड़ा सा फॉर्मूला याद आ रहा है तो फ्लक्स इज Li. Okay, in अगर AC को कभी हम डिटेल में we will study in electrodynamics, then we will understand why it is Li. For now, flux is equals to Li. So basically, it gives you L di by dt. It means the voltage in inductor is given by L di by dt. If your system is going no change means current is not changing, then your inductance is 0. But if your system has some change, then your inductance will be non-zero. So please note down this formula for phi and EMF and voltage. EMF basically means voltage. जल्दी से लिख लो ये. Okay, I hope it is written down by everyone. 3 formulas simple से लिखने हैं आपको. Okay, L is known as the inertia of electrodynamics. Everyone have a feeling of that. You know this. L is inertia. Yes, ये आपको पता रहना चाहिए.
Yes.
Voltage is 0, not inductance. Voltage is 0. Sorry. Voltage is 0. Basically, the circuit does not behave like a inductor. Voltage is 0. Obviously. L component itself will never go 0. है ना? चलो. Now let's put a AC signal with your inductor. It is just a symbol. It does not mean there is a coil there. It is just a symbol. Now, if I apply the voltage, again I am applying the same voltage, V equals to V naught sine omega t, and the current in the system will be I. And now we need a relation. Okay, so V is given by L di by dt. अभी हमने स्टडी किया V equals to L di by dt, and magnitude wise voltage is equals to L di by dt. Let's do di. Okay, I know voltage, I need to find current, so I need to integrate, right? So current will be equals to 1 by L into V into dt. Simply I just need to integrate, and I put the value of voltage is equals to V naught sine omega t. If you integrate sine, you get minus cos, so you have a minus cos here, and this is your current. This time this thing is known as I naught. I naught is equals to V naught by omega L. In the previous case, I naught was V naught by R. In this case, it is equals to V naught by omega L. So you can write it as minus I naught into cos of omega t. Okay? Or you can write it as this thing as sine of omega t minus pi by 2. Okay? Sine of omega t minus pi by 2. So you can do this. If you have to write this from this, so first what you will do is cos omega t ko you can write as sine of 90 minus omega t, because if you do sine 90 minus omega t, it gives you cos omega t. And then you can take this negative sign inside, because from sine negative can come in and out. From cos negative cannot come out, because if negative come out, it becomes positive only. But in sine, negative can enter and out because it's an odd function. So if I take a negative sign inside, you get omega t minus pi by 2. I hope now you understand why I gave you that exercise in the beginning. Okay. So your current becomes I naught into sine of omega t minus pi by 2. which basically means that your current is behind the voltage. Current is behind the voltage. Your current is lagging behind the voltage. So it means there is a phase difference between current and voltage, and current is lagging. Voltage is ahead. So if voltage is maximum now, current will be maximum after some time. If the voltage is minimum now, the current will be minimum after some time. Okay? And that has to happen. That has to happen. Why? Because once you put efforts, voltage, and your person is trying to resist the change. Let's think about Sheldon. Sheldon is trying to resist the change. That person does not like change. Amy puts the effort. Amy is like a voltage. Amy is putting in efforts. After some time, Sheldon will have some current, and basically the change in the Sheldon is like current. So then you will have the current. So current will follow. So current will always lag behind the voltage. Once you put in efforts, the current will come later. So if the efforts are maximum now, the current will be maximum after some time. So I hope it is clear. So please have this derivation written down. This is very important. These two are very important. लिख लो जल्दी से. And this statement is very important. Yes. Okay. Please note down. सबको समझ आया भाई? चैट बॉक्स में अंगूठे दिखा रहे हो तुम मुझे हैं? चैट बॉक्स में बताओ ना. Everyone is clear?
Yes.
Yes. Yeah.
Sir, is this important for Bach too?
Very, very, very. One-liner questions will come.
Sir, can you scroll down a little?
Yes, Siddharth, your voice is breaking. Yeah.
Sir, can you scroll down a little bit?
Yes, let's do it.
More little bit, like from there it started. Yes, sir. That's it. Okay, done, sir.
Okay. Okay, I hope everyone has written it down. Okay, a very interesting fact comes here. Can I say that V naught and I naught will be equals to the resistance? क्या मैं ये बोल सकता?
Sir, can you please repeat the question?
Can I say V naught by I naught is the maximum resistance this system can offer?
Yes, sir.
And is this resistance coming out of omega L from this relation? V naught by I naught is omega L. And do I say that it is known as XL, and XL is equals to the resistance of inductor?
Yes.
Yes. So I hope now you are clear that why we say resistance is omega L. So always remember this thing. Whenever I say what is a resistance given by inductor, you say it is equals to XL, which is equals to omega L. If I am only interested in the magnitudes, if I am also interested in the phase, I am interested in the phase also, then you should say J omega L. What is J? J is an imaginary number iota. Okay? J is an imaginary number iota. And why there is a J? Because you know Argand diagram. Argand diagram का नाम सुना है सबने?
Yes, sir.
Argand.
Yes.
So in Argand diagram, if this is your voltage and this is your real axis, yes, this is your imaginary axis. If this is your voltage and current is 90 degree, what? Current is 90 degree behind, or current is 90 degree plus?
Behind.
So this will be your current in Argand. Yes. So this will be your, it will be 90, current will be 90 degree behind. Okay. If current is 90 degree behind, समझ आ रहा है ना? So can I say that, okay, अभी यहाँ से थोड़ा सा tricky हो जाएगा. देखो, current is 90 degree behind. This is clear. This is clear. Now let's talk about resistance. Resistance is voltage by current. Okay. So this is V naught. This is something I naught, and I am just multiplying j is an imaginary number. ठीक है, j, let's say, okay, j is 90 degree behind, so I multiply by minus j. With current I am multiplying minus j. But do you think if this minus iota or minus j goes in numerator, it will become plus j?
Yes.
यहाँ पे मैं दोबारा इस बात को रिपीट करूंगा, रेजिस्टेंस इज इक्वल टू वोल्टेज बाय करंट. If voltage is on the real axis, it is simply equals to V naught. And if your current is on the imaginary axis, will I write I as I naught, or should I write I as 0 plus J I naught? Or I should write 0 minus J I naught, because the current is on the negative imaginary axis. क्या ये बात सबको clear आ रही है? Should I
Yes.
write my current as minus J I naught? Yes. If I write
Yes.
my current as minus J I naught, do you all know that whenever iota goes in numerator, the negative sign vanishes?
Yes.
क्योंकि आप कर सकते हैं, you can multiply divide by j. J is an imaginary number, okay? J is this, मतलब जो काम iota करता है ना, basically I am just writing j. Why j? Because I symbol is already taken by current, so I don't want to confuse. That is why we take j. So if you multiply but divide by j, then j into minus j is 1, and you have j. That is why you can clearly see in resistance you have j coming. That is why I said that resistance is j times omega L. I hope it is clear. If you need both the information of phase and as well as magnitude, then you multiply by j. If you only need the information of magnitude, then you simply say resistance is omega L. I hope it is clear how we relate our actual picture with the argand plane.
So can you please repeat?
Let's repeat. क्या रिपीटेशन करेंगे हम, देखो जरा ध्यान से देखना. लेट मी ऐड अ पेज हियर. इट्स वेरी इंपॉर्टेंट. वी कैन रिपीट, एंड आई थिंक इफ वी लर्न दिस हियर, then our life will be very easy. Let me do this. Okay, so these were my equations. Let me write my equation. So my voltage was V naught into sine of something, and my current is I naught sine of something, and both of them have a phase difference 90 degree. Let's make these diagrams in argand plane, complex plane. In complex plane you have real axis, you have imaginary axis. I was giving the voltage. So I gave the voltage. So this is my voltage. This is my V naught. So voltage can be written as V naught. Simply, मतलब कि voltage is a real number. So this is voltage. Basically, I'm writing it on the real plane. My current is 90 degree behind. So my current is here. So this is my current. This was my voltage. This is my current. Current is on the imaginary axis. So I should actually write my current as I into minus J. What is J? J is an imaginary number. जैसे I cap होता है ना, iota होता है ना, this is basically iota. The symbol of iota I am using is J. And why I am writing minus J? Because my current is on the negative imaginary axis. Okay, now I talk about resistance. What is resistance? Resistance is voltage by current. Voltage is basically a real number V naught. Current is basically a imaginary number minus J into I. Okay, so this is just simply V. This is minus J into I. Why minus J is there? Because current is on the negative imaginary axis. Why it is simply V? Because voltage is on the real axis. Now what I'm doing is I'm bringing this minus J on the numerator. If I bring this up, you get plus J. And this is my resistance, which is given by omega L. So I get J into omega L. That is why I said that if you also want the information of phase, you multiply by J. J is simply what? Iota. Clear to all?
Yes.
Yes. So please note down this. ये note down कर लो. This you can note down. Even you can make this diagram for a quick reference. Okay.
So,
Go on.
sir, where we can find your foundation classes lectures?
Go to app or website. Okay. Go to app or website. Login. First, login is very important. So there you will see login. You log in, your dashboard will open. Go to the foundation physics course. You will found there. You will see the foundation physics course written there. Enter it. Then you will see lessons. And then you will see class records. In the class records, you see all the previous recordings. Sometime I also put on YouTube, but don't wait for it. You can always access here. एनी टाइम। ओके, तो ये हो गई बात हमारी। नेक्स्ट करें, आगे बढ़े। आई थिंक द कन्वर्जन ऑफ डायग्राम शुड बी क्लियर। हाउ डू वी कन्वर्ट इक्वेशंस इनटू डायग्राम्स, फेजर डायग्राम्स?
Yes.
सबको क्लियर है ये बात? ये बहुत
So now
इंपॉर्टेंट है।
direction of the resistance in positive direction of imaginary axis.
नहीं देखो, देखो मैं यहाँ पर रेजिस्टेंस को ड्रॉ नहीं कर सकता ना। I don't say that this is my resistance. Okay, resistance is a final effect of voltage and current. I have already divided two complex numbers to get another complex number, but I am not drawing that resistance on my diagram because this diagram is for voltage and current diagram. This is a VI graph. Okay, or not VI graph, this is a phasor treatment diagram. I can draw, but I don't draw. You can draw. You can say this is your omega L. This is your XL. Yes, you can say. You can draw here because XL is equals to J into omega L. You can definitely make it, but we usually don't make it. But you can. There's no problem.
So
Okay. Can we now go for capacitor? Yes. करें capacitor?
Yes.
चलो capacitor की बात करते हैं. Now again I have a capacitor. I have a voltage source. Again my voltage is same, which is given by V equals to V naught sine omega t. Okay, now what will be the current? Can I say current is dq by dt? And can I say q equals to cv? क्या बोलते हो? q equals to cv? क्या बोलते हो? q equals to cv?
Yes, sir. Yes, sir.
So c is constant, c comes out, and you get dv by dt. You just differentiate this. If you differentiate this, you get v naught remains as such. Differentiation of sine is omega into cos. You get c v naught omega into cos. Now you tell me who is ahead, cos or sine? कौन आगे है?
Sine.
Cos.
Fine.
अरे cos और sin में कौन आगे होता है? पहली बात ही हमने ये की
Cos.
थी।
Cos. Cos.
cos एंड sin में cos इज अहेड। ठीक है, हमने बात की ना, cos ने पहले जन्म लिया, फर्स्ट बर्थ वाज cos देन sin. Okay, so it means this is ahead. And you can convert it like this also. If you want to direct compare, you can do that. And this is what we get. So basically what I got is that my voltage is V equals to V naught sine omega t, and my current equals to I naught sine of omega t plus 90 degree. Okay, can you tell me what is the phase of this? What is the phase in this equation?
Omega t plus 90.
Omega t plus 90. It's not 90. Okay, because this entire thing is phase. If someone asks you what is an initial phase, that is 90. Or if someone asks you what is the phase difference between them, that is 90. The phase of this is omega t, the phase of this is omega t plus 90. The difference of them is 90. And I naught is what? This is your I naught. I naught is given by C V naught omega. Okay. So can we convert this into again the diagrams? Yes, let's do it. Let's convert into diagrams. Let's do with me. ठीक है, वो आप सोचो, जयश्री दोनों ट्राई करो, try both, try with both, and then you will yourself realize the problem then why we should use one very particular thing. Okay, let's make a diagram. So again the diagram is something like this. This is your voltage. Again I am making the voltage here. Now my current should be where? This should be my current.
Yes.
So what should be my resistance? Resistance is given by V naught by I naught. V naught is V naught and I naught is what? Let's see what is I naught. I naught is C V naught omega. So I naught is C V naught omega. So I get 1 by omega C. 1 by omega C. Okay. So this is your resistance and what we call it as XC. What is the name of it, anyone?
Capacitive reactance.
Capacitive reactance. So this word reactance is very important. Okay. Reactance. Reactance can come because of inductor also. Reactance can come because of capacitor. Reactance means having a phase difference with voltage. So you applied voltage in this direction, but the current is either coming like this or coming like this. This is known as reactance. ठीक है. So reactance can come because of capacitor also and inductor also. If it comes because of capacitor, we call it as capacitive reactance. If it comes because of inductor, we call it as inductive reactance. So this is my voltage, this is my current. Perfectly fine. I am successfully happy with this. And Xc is the resistance by the capacitor. Now my question comes to you. Okay. Now my question comes to you. Should I write J by omega C or should I write minus J by omega C?
minus J upon omega
Minus
C.
J
Minus
by omega
minus
C.
J by
Minus J
omega.
by omega.
Minus.
माइनस सभी का दिमाग चल रहा है अब, राइट. Someone needs help, let me help them, because now current is written as plus j omega c, sorry, plus j v naught, and then the resistance becomes v naught by I naught, which is v naught by j times v naught, ठीक है, or whatever I naught, जो भी आपको बोलना है. Now the j was in the numerator. Now if it goes in the denominator, if it goes in the numerator, it becomes minus j. That is why you should use this formula. Okay, so you should use this formula. So it is minus j by omega c. Okay, so if you need magnitudes, then this is your resistance, and if you need also the phase, then you should use minus j by omega c. So this is your diagram, and if I have to make omega c, then this will be your omega c. Okay, if I have to draw the omega c. All clear? Yeah, yahan tak. One thing that we always have understood, that capacitor blocks DC. This we have seen, right? Capacitor blocks DC. This word we have seen. And why? Because DC mein omega is 0, and if omega is 0, Xc becomes 1 by 0 infinity. And it means infinite resistance. Capacitor gives infinite resistance to DC current. Why? Anyone? Physically, why? Mathematically we understood why, because omega is 0, DC में frequency नहीं होती, but physically why?
क्योंकि वहां पर कोई चार्ज नहीं होगा कैपेसिटर. अगर चेंजेस नहीं आएगा एक
चार्ज होगा या नहीं होगा?
आई मीन एक चार्ज मतलब बेसिकली जब उसका एक पॉइंट पे आ जाएगा, उसके बाद एक्स्ट्रा कोई चेंजेस नहीं आएंगे उसमें.
Why does your phone stops charging after 100%?
कैपेसिटी, मैक्सिमम कैपेसिटी उसकी उतनी है.
Basically, what happens? Yes, potentially same. Kanak ne gave a very good answer. Very good answer. Very good answer. Let's understand this concept and then we close today's class. Ek last concept we understand, and today's class we will be successful in this class. But this needs a very high concept. So if I need a high concept, I need your focus and I need your interaction. So try to give me an answer. If you give me an answer, your brain will work. So let's say this is my capacitor, and I apply DC voltage. DC voltage. Fixed voltage, 10 volt. And this is uncharged capacitor. The moment I connect, let's say there was a switch. Moment I close this switch, do you say that this capacitor will start getting charged? Yes or no? Will this capacitor start getting charged? Yes or no?
Yes, sir.
Yes, sir.
Yes.
When it is getting charged, is any current flowing or not flowing?
Not flowing.
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 Correct. Current is flowing. Why it is not flowing? Tell me. When you put a phone on charging, no current is flowing in your phone.
Yeah, yes.
बताओ भाई, लॉजिक बेसिक दिमाग क्या बोलता है भाई? बेसिक
Flowing.
करंट फ्लो कर रहा है ना.
So
But
basically,
now
there is a potential difference between the capacitor and DC voltage source.
अभी मैं कंफ्यूज करूंगा. You said current is flowing, but it is a DC voltage. So omega should be 0. If omega is 0, XL should be infinite. Resistance is infinite, so no current should flow. Then why the current is flowing?
Why are we talking about XL? Here is C, na? XC.
नहीं मतलब AC से DC में जाना हो तो क्या करते हैं? हाँ, XC is infinity and no current. XC. So why the
सर
current is flowing?
इनिशियली तो फ्रीक्वेंसी जीरो नहीं होगा ना,
है,
क्योंकि
yes,
चेंज हो रहा है।
What is your कृष्ण भगवान ने हमें रास्ता दिखा दिया. So देखो he is correct. The question is the current is flowing. Is this current constant or is this current changing with time? When you put your phone,
Constant.
when you put your phone on charge, first 15% happens very quick.
Yes.
Last 10% takes most of the time.
Yes, sir.
Yes.
It means my current is not constant. My current was initially very large and then it became constant. Can I say this?
Yes.
Yes.
Initial, when you put your charger, so you see, if you put your charger at 1%, within 30 seconds it is 5%. You see fast charging happening, right? Very quickly the initial charging happens. So initially the current was changing. So when the current is changing, can I say that the voltage on this capacitor is increasing? If initially it was 0, it is slowly becoming 1, 2, 3, and ultimately it will become 10.
Yes.
The moment it become 10, the voltage of capacitor and voltage of battery became equal.
Yes, sir.
In that case, do you think the current will flow?
No, sir.
Oh, sir.
When your phone is 100% charged, 100% means what? 100% means I am same as battery. Because universally 100% is nothing, right? Phone का 100% का मतलब क्या है? That now I am equivalent to your capacitor. I am equivalent to your battery. So my voltage is same as your battery. So initially it was not same. Initially it was at 0. I gave 10 volt. So iski voltage. So when I gave 10 volt, the current started to come. But slowly, this current starts to become constant. Or this is voltage. My voltage starts to increase, and ultimately my voltage became constant. 10 volt. It became same as 10 volt. Initially my voltage increase, and then it became 10 volt ultimately. Similarly, current. Initially there was a current and then finally the current became 0. This was my current. Current was initially there and then it became 0. So now you tell me, during charging, current is constant or time changing? That's my question.
Time
Current
changing.
time
changing.
Now everyone can imagine it is time changing. And if it is time changing, can I say omega is 0? Can I say this? No,
No.
because it is time changing.
No.
It means omega is not 0. Omega is not 0. If omega is not 0, can I have xc? Xc will be not infinity. And if I have xc, can I have current? Everything is okay.
Yes.
Yes.
So the only idea here is, even if you apply DC voltage to a capacitor, the current which flows in the circuit is not constant. Voltage is constant. Voltage of the battery is constant. But the voltage across this capacitor is not constant. This is not constant, because you can see, if your phone is there and you are putting a battery, it means the voltage of my phone is increasing with time. Similarly, the current in my phone is decreasing with time. As the voltage keeps on increasing, the current keeps on decreasing, because this phone now don't needs that current. Ultimately the voltage becomes 100%, the current becomes 0. That is why even after entire night, your phone automatically gets cut off. Right, after 100% it automatically gets cut off. Even if there is a person here, it will not charge, because it's already 100%. So voltage becomes maximum, current becomes 0. So during that charging phase, the current was changing with time. If the current was changing with time, then it is not good to say that your omega is 0. Even though you have applied a constant battery, still the current and voltage are changing with time. That is why omega is not 0. and if omega is not 0, xc is not infinity. So hence the current can flow in the circuit. Okay, so I will stop here. Tomorrow we will connect three together, R, L and C. All three we will connect together, and we will see if we connect in series what happens, and if we connect in parallel what happens. So today I will give you some questions based on today's class. So you try to solve that out. The questions will be there around by 10:30. I will provide you the questions. So it will give you the good practice. So tomorrow we will connect them and we will complete the story. And then after that, after day, we will study these circuits. What happens when we apply the constant batteries. So that's all for today. Any doubt you have, go ahead.